Wow, thank you for having me. It is awesome to see such a full room. Like, it's kind of hard to believe that, so many people come to conferences that we don't even throw, and I get to be part of. So I really appreciate that, and I appreciate all of you guys coming and being part of this awesome journey. So first, I would like to talk a little bit about our community. So last time this year, we had about 1.1 million active users. This is people who come and visit our documentation. We assume that if you're reading our documentation, you're using Angular. This time next year, as you can see, we're up to 1.2 million users, which is a little bit of growth. But the big thing is we've gone to from almost nothing in Angular 2 to almost over 700,000 in Angular 2. So if you add 700,000 to 1.2 of existing users, that's almost 2 million Angular 2 developers that we have now with our community. So we're very proud of that, and you should give yourself a round of applause for being part of this awesome community. So with Angular 2, we really wanted to solve the whole end-to-end experience as a platform. Everything, obviously, you wanted to build web pages, so we can do that. We also wanted to make sure that you could build mobile application, and whether it's something like Ionic, where it uses DOM rendering, or native, which is something like React Native or NativeScript, are also ways in which you can build your mobile applications. We also are focusing on so you can build a desktop application through something like Electron, so that you can wrap your Chrome into what looks like a desktop app. So whatever target platform you happen to have, Angular can help you build that. So the framework has a lot of different parts to it. So first of all, we have the basic things like the compiler, the change detection, the renderer, which is both can be serialized across web workers and also across platforms such as native rendering and obviously DOM. Dependency injection, decorators, which allow you to bring the power of declarative UI not just to templates but also to code, and zones, which make sure that you never have to worry about scope that apply in your code base. On top of that, we've added material design so that you have widget libraries that you want to write on. We have a heavy focus on mobile devices and mobile building, making sure that we can run inside of a constrained device. And universal, which is a pre-rendering of the application on a server before it's rendered, so that you can have things like search engine optimization and very quick first time to render. On top of that, we give you command line interface so that you can build applications quickly. We have language services, which I'll demo for you, and Augury, which is a way of getting a better insight into what's happening in your application. We have ng upgrade so that you can migrate Angular 1 to Angular 2. And we have things like router and animation and INTN. So what I want to point out is that we really wanted to look at the whole thing holistically, end to end. And we wanted to solve everything you need for building a web application. It could be a one-stop shop where we figured out all the pieces. It doesn't mean that we are an exclusive club. You can obviously bring in whatever other technology you happen to have. But we made sure that our set of technologies are easy start for you so that you don't have to figure out everything from the scratch. Now, today I really want to talk about performance. Now, performance is a very complicated thing, and there's a lot of different parts to it. There is the time it takes to first show an application, the time to first render, how long it takes once the application running to change from one location to another, to change routes, how long does the change detection run, and how much memory you create. And so all of these things really have to be accounted for, and it's oftentimes people make blog posts and they give a single number and they compare frameworks, and I really think it's a much more complicated story, and so I wanted to kind of focus on that today a little bit. So with rendering, we got about 2.5 times faster than Angular 1. Then we redesigned, and the reason why we could have redesigned is because so much of the application is declarative. And then when we redesigned the code, we got about 4.2 times faster. And turns out Tobias loves to redesign, so he did it again, and now he's about 5 times faster. And we are still not done. This is what's available today. We already have a bunch of ideas in our head as to how to take that 5 times faster and double it one more time so that we can maybe hit about 10x faster from Angular 1 to Angular 2. This is for rendering performance. Now, as far as performance goes, there's really 2 broad categories. There is really size, which is how do you make it smaller, and how do you chunk up your code into smaller pieces. And sorry, it's jumping. And how to make it faster. So let's focus on how to make it smaller. So in Angular 1 and in Angular 2 JIT mode, the way it actually works is you have your HTMLs, your CSS, and your annotations that come in and get fed through the compiler that munges on it and provides internal data structures to kind of glue all the pieces together. then that kind of glues your application code with our internal data structure so that we can do the rendering for you, so change detections, DI, and so on. What we've done in Angular 2 is we now introduce ahead-of-time compilation. And with ahead-of-time compilation, we can take many of these steps and make them as a build part. So instead of every time the browser comes up, it has to perform all these things like parsing HTML and putting everything together, we can offload that as a build step for you. And then what you ship to the user is just the bits that they need. So the first advantage is that the amount of bits you ship to the user is smaller because you don't have to ship the compiler, the parsers, and so on. But also, it turns out that when we generate code, we can actually skip a whole bunch of things. Mainly, sometimes we can look at dependency injection and we can know exactly which component at compile time we actually gets injected, and we can wire it up directly, completely bypassing the DI runtime information. And so on for other pieces as well. So the end result is that we can get a hello world down to about 25K, give or take a bit. We're not done. We can still do better. And we are planning to get at least 10K for hello world. But this is just kind of how we're getting started. And the key thing here, the reason why we can do that over and over again, is because so much of the platform is declarative, which means we don't specify how exactly it's done. We only specify what the end result is. And as long as the end result stays the same, we're free to change the underlying implementation to give you better and better performance over time. So we start with an offline compilation, which generates the code. We then feed it to, what we do is we inline the modules. That's because with ES6, modules are a great way of breaking up your large application, but turns out they do have a cost. The import and exporting of your files actually translates to some runtime costs. And with inlining, we essentially concatenate and resolve all the imports and exports ahead of time. It's really a fancy concatenation of the files. The next thing we can do is we can tree shake it away. So if you don't use a particular directive like ng class or ng switch, we don't ship it with your application. We only ship the parts that you need. And so this is, again, a place where we can tree shake away all the compilation and compiler and the parsers because it's precompiled at build time. And finally, we can run a minification step on it, which is kind of like your Uglifier or Google Closure compiler. Then the nice thing about it is, because we can generate code, we can actually do something better. So here's an example of kind of a hello world. And notice how on the right-hand side is a reflective code that kind of reflects over the object and references the property to see if it has changed. The problem here is that if you run it through a minifier, the minifier is not allowed to translate the properties. If it minifies, if it mangles the property name to something short like an N, this will break because the template still has name with double curlies. Now, you could fix it by teaching the minifier how to understand Angular's templates, but in practice, nobody does this because, well, it will be specific to one framework. So what we do in Angular 2 is we actually we generate code that looks like this. And now the template is no longer needed, and the minifier is free to rename the property just as well as it renames everything else. So currently, with this particular optimization, you can probably get another 50% improvement in size just by renaming the properties inside of your application. And this is something that wasn't possible before with Angular. Now, the other thing we do is we turn all of your code into modules. And modules are kind of boundaries for that compiler, and it's also boundaries in terms of like chopping up your application to smaller pieces. And we can load the modules lazily for you. So normally you have an application, and application has a hierarchy of injectors. You have a platform injector and the main module that's loaded, and then maybe a couple of components and a router. And router can go ahead and load other modules into itself. And by loading these modules, the router can you can take your large application and break it up into smaller ones. And as the user navigates to different locations, only the parts that the user navigates to are being lazy loaded. Now, what's added to it further is that our router can do speculative loading of modules. So before the user actually navigates to a particular location, we already prefetch the modules, and we're ready to go as soon as the user clicks on it. So this basically allows you to take a large application and kind of break it up. So we talked about how to get this size smaller. Now let's talk about speed. Like what can we do to make the application run faster? Again, let's look at the simple example of Hello World. And this is kind of how Angular 1 worked, which is that you have a while loop, and you iterate over the different properties that you have to look at. This is what r.object is. This will be your scope in Angular 1. And then you look at different properties on it, which, as you can see in the square bracket. Turns out that the two red boxes that you have on the screen, those two boxes account for more than 90% of the execution time of this loop. And so you might be wondering why that is. And the reason for that is because VMs do something called inline caching. And inline caching basically means that as the VM is running through the code, it notices that the shape of the object, in this case R standing for record, is always the same. It's always the same looking object that's coming in here. And so instead of treating R as a hash map, the VM says, oh, R is actually a real object that has a bunch of slots where properties are being stored. And it simply VM memorizes that r.object is the first location, the first slot in the object, r.property is the second one, r last is the third one, and so on and so forth. So when the application runs through it, when the VM runs through it, it's very efficient at dereferencing the object. Now the problem with the red box is that the object on the left-hand side, the r.object, always resolves to a different object. Every time you're running through a different component in your application, the shape of the object on the left-hand side is always different. And on top of that, the property that you're dereferencing is always different as well. And so when VM kind of sees this, it eventually just throws its hands up in the air and gives up and says, you know what, I just cannot do this fast. And it falls back to the slow execution time. This is called polymorphic code, and polymorphic code is what makes JavaScript slow in this particular case. When we generate the code, essentially we unroll the loop. And by unrolling the loop and generating the code explicitly, what happens is, notice the r.object turns into context, which is a specific type, and .name is a specific property that always references in here. And so when this executes, the VM notices that the shape of the context is always the same because it's the same, in this case, a greeter class. And then property is always the same. And so the VM can do the same exact operation when it's more efficient over here as well. And so the result between the left-hand side and the right-hand side is that the right-hand side runs 10 times faster than the left-hand side. Now the other thing we do is when you take your template and we turn it into the generated code, we put type information for TypeScript in there. So in this case, you can see the context has a type called greeter. And then we want to remember the last value of the name as we're dereferencing it. So we say that the last name is the same type as the type of the context.name. This is one of the cool things that TypeScript can do. So because greeter defined the type of name to be a string, in this case, the last name also becomes a string. And so on for the local variable v. And now we can compare the last value to the current value and do some operation on it. And so in this particular manner, the code we generate, which is basically from your template, is fully typed. So if you, inside of your template, accidentally introduce an error or a typo, TypeScript will come and tell you that the type does not match, or you're dereferencing a property that doesn't exist, and so on. So we're trying to push as many of these errors to compile time as possible so that you don't have to run your application to see these problems. Now in Angular 1, usually a typo would be silently ignored, and then you would never really find out that you had a typo. With Angular 2, we're pushing this stuff to the build time, and you're getting proper error messages. Now let me show you how this actually works in practice. So one of the things we have is we have language services. And language services is a service, is a daemon that runs in the background in a separate process, and constantly is parsing your template. And so you can see that as you're writing the template in here, you can see full completions going on in here. So we can dereference, we know that we have a title property. We know that me is some kind of an object that has a birthday property, which happens to be a date. And as a result, we can call get month on it, and we can call a particular pipe on it. We know what events things have. And so we can see if something's mistyped, it complains about it. And so the nice thing is, because it's a service, it's very easy to integrate with any kind of IDE. You just write a little plugin for your IDE that says if you hit some key combination, make a HTTP request to the service and says, I am in this location in this file. Please verify that this is correct, or that what is the completion, what are the possible completions at this location. And so you can get these kind of benefits, hopefully, in just about any IDE. Now, this kind of thing isn't really possible in Angular 1 because the templates were not fully analyzable, but it is possible in Angular 2. The other nice benefit is that you get proper error messages. So if there is a runtime error, instead of getting a stack trace that contains a whole bunch of Angular stack frames that only make sense to the initiated, you now have a stack trace that points to a specific location in the generated file. And if you look at the generated file, usually you can immediately recognize as being part of the template that you come in. Usually we leave comments behind from which location the template we extracted, and the expressions that are in here are the expressions you placed inside of your templates. Now we do also have our own HTML parser. That's because browsers are notorious that no matter what kind of a garbage you put in, they tend to parse it without any sort of error or warning or anything like that. And so now we can, for example, tell you that if you say something like div and you say tab index, we know that there's no such thing as a tab uppercase index. Instead, there's a tab dash index, so we can give you a warning about that. We also know there's no property called label on side of the div, and that the div in the future will be able to tell you that div doesn't have a slide event. And of course, that you didn't close it properly. And on top of that, we can actually give you proper line numbers. All of those things are really not possible unless you have your own parser. And because this parser is running, is our own code, we can run this parser in WebWorker, and we can run the parser on a server side to get all the other benefits. So I showed you how we can make change detection faster, about 10 times faster. But the next thing you could do is, if you make something 10 times faster, it's still not fast enough, you can figure out how can I do less of it, right? So there's a tree of all the change detection you have to do. What you want to do is you want to prune the tree. Instead of checking the whole world all the time, how about I just check the subset of the tree on as-needed basis? So by default, you get the blue box, which is called the check always. This is the change detection you're familiar with Angular 1. But you can go into different modes. You can, for example, say, you can programmatically detach the branch, saying, like, I know this will never change, so don't bother dirty checking it. So you can detach it. Or you can go into conditional dirty checking, where you say, this only changes when the inputs have changed, which is what the yellow on push is. And then we're working on the green on dirty, which basically says that the code programmatically will tell us when to do rendering. And think of it as a scale. You know, on one side, you have to do very little, and you get great performance. But on the other side, you might have to do a little more work, but you have more control. And so you can choose whichever one falls into, whichever one is needed best for your application. The other thing we can do is, because we only do a single pass, and we do from top to, the change detection goes from top to bottom, we can give you proper hooks, like before child init, after child init, and so on. So the final thing is we are looking at a memory pressure of the application, because oftentimes on mobile devices, the size of the application matters in terms of how much memory you use and how often the GC runs. And so we're really worried about how do we optimize this. And so minimizing the data structures and change detection garbage as it's run is important to us. And the way we can do this is that when we generate source code, as we said, many of these internal data structures that keep track of things fall out, and they naturally just become the generated code. And it turns out the generated code is a lot more efficient in terms of amount of memory you have than having a generic code that kind of reflectively deals with the system. And finally, a lot of web applications, a lot of mobile devices today have more than one CPU, and so you want to be able to take advantage of the secondary CPU. But JavaScript is single-threaded. But what we can do is we can run the application on a web worker. So we can run the application in logic on the web worker, also the XHR, the data, etc. And then we have a serialization pipeline that takes the output and serializes it into a stream, which can be then deserialized on the other side, such as a DOM renderer, which is a second CPU, which deals with rendering, animation, layout, and so on. And so you can take advantage of that. And theoretically, the web worker doesn't even have to be on the same machine. It could be on a server and a client, although I'm not sure why you would want to necessarily do it this way. But the point is that you have a lot of different choices. And again, all of this stuff is mainly possible because so much of Angular is declarative. Now, how do we know that we're getting faster? So we have this thing called the bench press, which is essentially a browser runner which connects as if it was a debugger. So all of the benefits, all of the capabilities of, if you do inspect element and you go to your dev tools, all the things you see over there is what our bench press sees. So we see memory pressure, we see execution times, render times, how often things render, and so on. And we have sample applications that we run inside of the bench press. And what's interesting is that if, for example, we accidentally check in something that makes something slower, we immediately see that the performance of these applications go down. We can revert that or fix to get it up to speed. And we constantly strive to make it go faster. Now, how do you know what the theoretical limit is of how fast can you go? Let's say you get some number. Let's say your application runs at 5, speed of 5. Is it good enough? Can you make it better? How do you have the motivation to make it better? And so what we do is we re-implement all of the applications twice. Once inside of Angular 2, and the second time we hand-code it with every single trick imaginable that we can think of. And then we compare the performance of the Angular 2 application using the framework versus the hand-coded version that we have painstakingly optimized. And because of that, we know what is the theoretical limit of how fast we can possibly go. And so one of these kind of optimizations just recently, we have figured out how to make some of the rendering about twice as fast than it is currently. So the performance improvements are still coming. And we know that there's more room to grow because we know how to compare it against what's theoretically possible. By the way, bench press is also something that's available to the outside community. So we recommend that if you're building an application, you also look into it and start using it as well. OK, so we kind of talked about the framework, but let's talk about now a little bit about the stuff that's around it. So we mentioned the language services already. Let's look at the command line interface. So we have a CLI where essentially with 4 commands, you can get a hello world up and going. You install Angular CLI. You ask it to make a new project. You go into the project and say ng-serve, and you're ready to go. It sets up basically everything. The pipeline for building it, the tests, the end-to-end tests, the bundling, everything you need to kind of get going. And so the only thing you have to focus on is now how do you keep adding value to your product. There's commands for creating new routes, new components, and kind of managing the whole lifecycle for you. Now, we already talked about how we do the ahead-of-time compilation by doing the offline compile versus JIT. Here's some of the benefits, right? We talked about how we can do type checking, how we can tree shake away components and features that you don't actually use, how the minification is better because we can not only minify property names, not only minify variable names, but also property names. It also inlines templates and CSS, so you don't have to do secondary HTTP requests to get those resources. It is security people love this because we don't ship the parser and interpreter. And as a result, it's so much more difficult to have a security exploit because there's nothing to execute the code in there. And it is CSP safe in case you wanted to build an Angular 2 application as an extension for a browser or have a CSP website. Augury is a tool that is an extension. This is by Wrangle.io, which is an extension to the dev tools. And as the debugger does for your individual lines inside of your application, the Augury does the same thing for components inside of application. So you have a high-level view of the components and how they're instantiated. You can look at the injectors, how they came to be. You can look at the routes. You can explore different properties of it, how things are assembled. And you kind of get an inside view of what's going on. And finally, we have Angular Universal. And this is where we can run the whole framework on the server and pre-render everything ahead of time. So that when a crawler comes to your website, like SEO, we can serve a static page. But more importantly, if you have an application, we can send across a pure HTML and CSS code, and then have the application update itself once the rest of the code base comes in. It is even smart enough to record all the interactions of the user and then play back those interactions once the framework is fully rendered. Anyways, that's all I had. Thank you so much, and enjoy your conference.